All right, so let's talk about unit vectors. So the unit vector is a vector whose magnitude is 1. Okay. So definition. A unit vector is a vector with magnitude 1. For any non-zero vector, we can use scalar multiplication to find a unit vector that has the same direction as that vector itself. So for any non-zero vector v, we can use scalar multiplication to find a unit vector u that has the same direction as v. So to do this, we multiply the vector by the reciprocal of its magnitude. So this is the rule that we're going to take advantage of. The vector u equal to 1 divided by the magnitude of our vector v times vector v is a unit vector so that it has magnitude 1 that's in the same direction as our vector v. So recall that when we defined scalar multiplication, we noted that the magnitude of a scalar times a vector was the absolute value of that scalar times the magnitude of the vector. So essentially it comes down to the fact that our vector u, which is 1 over the magnitude of v times the vector v, has magnitude equal to the absolute value, the magnitude of u is the magnitude of 1 over this number here, v, which is just the absolute value of this, times the magnitude of our vector v. And when we do that calculation, we just get 1 over the magnitude of v times the magnitude of v, which is 1. So that's our proof. So we say that u is the unit vector in the direction of v. This is actually also a definition. All right, so the process of using scalar multiplication to find a unit vector with a given direction called normalization. Right, so the process of using scalar multiplication to find a unit vector v with a given direction is called normalization. Right? So it's just this idea that if we have a particular vector, right, all we have to do is figure out how long it is and shrink it so that the length is just 1, and this is our unit vector. So the key thing is that we are keeping that angle the same.